Using the power of a quotient rule. Simplify each of the following quotients as much as possible using the power of a quotient rule. Write answers with positive exponents. Looking at example A, the quotient that I have, or the fraction, is b to the fifth over c, and that whole fraction is being raised to the third power. The way that we will tackle this is to take that exponent of 3, and raise both the numerator and the denominator to that exponent of 3 separately. In the numerator, I've got b to the 5 times 3, or b to the 15th power. And in the denominator, we've got c cubed. So this is our answer here. Looking at example B, I'm going to raise the numerator 5 to the 4th power, and then I'll raise the denominator u to the 8th to the 4th power separately. Let's see, what's 5 to the 4th power? 5 times 5 times 5, 625. And then I've got u to the 8 times 4 power, or 625 over u to the 32nd power. Example C, I have a -1 raised to the 35th power, and then w to the 3, w cubed, and then to the 35th power. Now looking at the numerator, I've got -1 times -1 times -1. I've got that 35 times. So I've got an odd number of them. When I have -1 times -1, that'll be positive. So anytime I have a set of pairs of them, that'll be positive. I've got an odd number here, so it looks like I'm going to have a -1 left over. So that's going to be -1 overall. In the denominator, we've got 3 times 35 for our exponent. And that is 105. And then looking at example D, I'm going to write p to the -4th and then raise that to the 8th power. And then I'll take q cubed and also raise that to the 8th power. That 8 that's on the outside is going to be acting on both the p and the q. So I've got p to the -4 times 8 and q to the 3 times 8, or p to the -32nd power and q to the 24th power. We don't want to have negative exponents, so we'll leave the q in the numerator and move the p down to the denominator. And then for our last example, E here, I'll rewrite this as c to the -4th and then raise that to the 4th power. Again, this 4 on the outside is distributing to both of those. And then I've got d to the -3rd power, also raised to the 4th power. So this is c to the -4 times 4. I'm taking those two exponents and multiplying them together. And d to the -3 times 4. Or c to the -16th power times d to the -12th power. Both of these have negative exponents, so we'll write them down in the denominator. C to the 16th, d to the 12th. Moving on to example 9. Simplifying exponential expressions. Simplify each expression and write the answer with positive exponents only. So this is sort of combining everything that we've learned in this section. For example A, I've got 3 separate items that are in parentheses, 2, u, and v squared, and they're all being raised to the negative third power. So I'll write 2 to the negative third power, u to the negative third power, and v is going to be taking those two exponents, 2 and negative 3, and multiplying them together. Let's see. Those negative exponents, I want to write them. Let's do a little simplification first. Let's write 2 to the negative third. We'll leave you alone for a minute. And then what are we going to have here? V to the negative sixth power. 2 times negative 3 is negative 6. All right. So it looks like all 3 of these items should go down into the denominator. Let's write 2 cubed, u cubed, and v to the 6th. They all have negative exponents, so I'm moving them downstairs. And then the only thing left to simplify would be that 2 to the third power. 2 times 2 times 2 is going to give us 8 u cubed v to the 6th. Looking at example B, I have 3 items that are multiplied, and their bases are all the same, which is x. That means that I can add the exponents. So I would add, I've got an 8 as one of the exponents, I've got a negative 12 as one of the exponents, and I have a 1. 8 minus 12 gives us negative 4, plus 1 is a negative 3. Again, we don't want to write our final answer with negative exponents, so we'll write the x cubed in the denominator. Example C. I've got a lot of things happening here. I've got 2 items in the numerator. I've got 1 item in the denominator. That 2, that's the main exponent on the outside, has to be acting on every single component that's inside the parentheses. So let's do this sort of systematically. All right, first I've got e squared, and that'll be raised to the second power. And then I've got f to the negative third power, that is also raised to the second power. And then f to the negative 1 raised to the second power. That 2 that was on the outside, I can see, has been distributed to every single item that was in the original set of parentheses. All right, so e squared and then squared again is e to the 2 times 2. Then I'll have f to the negative 3 times 2. And in the denominator, f to the negative 1 times 2. So I've got e to the 4th, f to the negative 6th, and f to the negative 2nd power. So we still have a little bit of simplification that we can do because we've got f in the numerator and we've got f in the denominator. It looks like if I combine those two together, the quotient rule tells us that we can subtract the exponents. So I have negative 6 minus a negative 2 from the denominator. This is going to be e to the 4th times f to the negative 6. That's going to change to this right here. I'm running out of room here. This part right here is going to change to negative 6 plus 2 because I've got a negative times a negative. So that will give us negative 4. So I think my overall answer should be e to the 4th over f to the 4th. All right, let's move on to example D. I'm going to make a little bit more room here. All right, I'm back. I paused a second so I could make a little bit more room there. All right, looking at example D, I've got 2 items that are being multiplied together. I can see that in both of the sets of parentheses, I've got R's and I also have S's. So I'm going to maybe kind of group together the things that are alike, the terms that are similar. So let's maybe put the numbers together. I have a 9 times 3, and then I've got r to the negative 5th power and r to the 6th power, and then s to the 3rd power and s to the negative 4th power. Got a bunch of things that are kind of similar there. So let's see. 9 times 3 will give us 27. I've got r to the negative 5 plus 6, which will be r to the 1st power. And then I've got s to the 3 minus 4, which is s to the negative 1st power. So it looks like overall, my answer is going to be 27 r over s. Moving on to example E. Before we get too much into this particular problem, we probably want to just step back for a minute and notice that, oh, I've got an error in this problem. Let me pause for 1 second. Okay, I just fixed a typo that I had. There was a W right here that was missing. Because what I wanted you to see is that what I have here in parentheses are identical. And so the bases, those are the bases, and the two exponents that we're looking at are a negative 3 and a positive 3. So if I write this in a more simplified way, my base, 4/9 t w to the negative 2nd power, I'm taking the negative 3 and adding 3. I'm adding those two exponents together, which ends up being a 0. And we know that anything, no matter how complicated it is, raised to the 0 power is just equal to 1. The point for this problem is before you start taking that negative 3 and positive 3 and sort of moving them into each of the items, just take a step back and look at the overall problem and see if there's something that's a little bit easier to simplify before you move on. All right, example F. So let's just look at the numerator separately from the denominator to start, and then we'll start kind of simplifying items that are alike. I'm going to start by taking that 4 that's the exponent and moving it into each of the items in the numerator. So I'll have 2 to the 4th power, h squared to the 4th power, and then k to the 4th power. Using that same idea for the denominator, I'll have 7 squared, h to the negative 1st power, and then squared, and then k squared and squared again. So I took this 4 and moved it into all of these items, and then I took this 2 and moved it into all of these items. Okay. 2 to the 4th power is 16. I have h, 2 times 4 gives me 8, k to the 4th. 7 squared is 49. On h to the negative 1 times 2 is negative 2. And then 2 times 2 is 4. All right. Now the last part is to kind of simplify. I've got h's in both numerator and denominator and k's in both numerator and denominator. Looking at the k's, that's really easy. They're exactly identical, so those are going to go away, right? They're going to cancel each other. So the 16 will stay up here. The 49 will stay down here. But it looks like I've got h to the 8th minus a negative 2, or similar to a problem we had a minute ago, this is going to be 8 plus 2. I've got subtracting a negative number. So my final answer here is 16 h to the 10th power over 49. So these examples are putting all of the items together, and hopefully you have a good sense of how to work on these. If you have questions, feel free to reach out.